Alright, here comes one more video on finding zeros. Now we're going to have to factor completely and list all the zeros, but if you remember a few videos ago, I said sometimes you're going to factor with synthetic division. I'm going to show you how to do this entire problem using only your graphing calculator and synthetic division. So to do this, what you're going to need to do is you're going to need to type that into Y1 of your calculator. And what you're going to need to do is you're going to need to sketch out the entire graph just for yourself. So if you were to sketch that graph, it would look a little something like this. And what you would need to do is you would need to find one of those 4 zeros. So I'm going to pick that one over there, which is 2. Now what we're going to do is we're going to use synthetic division with the 2. Obviously you could have used a few other choices, but all you need to do is pick one. So then on the inside we're going to have our 2, 7, -4, -27, and -18. And we're just going to use synthetic division here. So drop the 2. 2 times 2 is 4. 7 plus 4 is 11. 2 times 11 is 22. -4 and 22 is 18. 2 times 18 is 36. Plus a -27 is going to give you 9. And 2 times 9 is 18. -18 and 18 is 0, which is exactly what you want. You want no remainder. Now we know that's 2x cubed plus 11x squared plus 18x plus 9. But like I said, I'm going to teach you how to do this entire problem using synthetic division only. So if you were to take this 2x cubed plus 11x squared plus 18x plus 9 and type that into Y1 of your graphing calculator and get a new graph, your new graph would look a little bit like this. So from here, what are you going to do? Well, you're going to pick another 0. Notice that 2 is no longer available in this one. So pick one of your other 3 that are left over. I'm going to pick this guy. His name is -3. So what we're going to do is we're going to go back and we're going to just watch this, drop another big L, and put the -3 in front, and watch. We're just going to use synthetic division again. So bring the 2 down. -3 times 2 is a -6, and 11 minus 6 is 5. -3 times 5 is a -15. 18 minus 15 is 3. -3 times 3 is a -9. We have no remainder. And guess what? We're still not done. So we type 2x squared plus 5x plus 3 into Y1 of our graphing calculator. And you're going to graph one more time, and you're going to see this. And you're going to find one of those 2 remaining zeros, and one of them is actually a fraction. So I'm going to go with the non-fraction right here. His name is -1. So one last time, we're going to drop another big L, except for we're going to have a -1. Drop your 2. -1 times 2 is a -2. 5 minus 2 is 3. -1 times 3 is a -3, and guess what? Now you are finished. So this is your 2x plus 3 when you are done. So if we were to go all the way back, remember we are factoring completely and listing all the zeros. So we have a 2x plus 3. Don't forget anything else you're using. This is x minus 1 came from, this -1 came from x plus 1. This -3 came from x plus 3, and this +2 came from x minus 2. Look at that. You just graphed an entire problem using just synthetic division, graphing, factoring, everything. It's all done. The only thing you have left to do is list all of your zeros, and all of your zeros would be x is equal to a -3/2, -1, -3, and a +2. And that's it. An entire problem factored using only synthetic division and a graphing calculator. Check that out. All right, so that's just, me showing you how to use synthetic division. Synthetic division does not always have to, or doesn't only have to be used once. You can use it for the entire problem. So what I'm going to tell you to do with this problem, notice I'm just going to give you a red flag here. There is no x squared. So if you're going to use synthetic division, make sure you use it appropriately. I'm just going to say, you know what? You have a toolbox full of tools right now. You go factor this completely and list all of the zeros. And come check back to the video in just a second when you're done. Click pause. Do not forget, synthetic division is just one form of factoring, but in this case you didn't even need to use it at all. You have choices sometimes, and this could have just been factored using grouping. Group the first two, group the second two. You factor out a GCF of x cubed, leaving you with x plus 2. Factor out a negative 8 for your GCF and leaving you with x plus 2. So remember, the insides get written once, and your GCFs get written together. But then you have an x cubed minus 8, so you have to use the difference of two cubes. Same, opposite, plus. Cube root of this is x, cube root of that is 2. Square them, put them in the front and the back, and 2 times x is 2x. And don't forget about your x plus 2 that you have already. And then you set all three of those terms equal to 0, and you'll get a 2, a negative 2. But this, again, you have to use quadratic formula or completing the square if you'd prefer to solve to get your third and fourth zeros. If you were to look at the graph again, you would see that it crosses twice, which means you have two real zeros. But since this is x to the fourth power, you should know you're going to have two imaginary zeros. Okay? Now, if you use synthetic division but got the same answer, that's fine. If you have this completely factored correctly but you weren't sure what to do with that, remember that's just solving a quadratic, so you could use completing the square or the quadratic formula. So, there's only one more problem left, and it's a biggie. We're going to tie everything together in one problem. So we're going to be given the function f of x is equal to x to the fourth plus x cubed minus 8x squared minus 30x minus 72. So yes, you're going to want to type that into y1 of your graphing calculator. And then you're going to press graph. And the first thing it says to do is sketch the graph. So that's exactly what we're going to do. We're going to give the graph a little sketch here. And the graph is going to look a little something like this again. And we have two zeros there. And if you would like, you can find them right away. And you have a negative 3 here, and you have a 4 here. So that's the first step, is to sketch it. Now that we know that this is an x to the fourth power function, and we have how many possible solutions? There are 4 possible. Just by looking at the graph, how many times does the graph touch the x-axis? Twice. Are any of them bounces? No. So there are 2 real solutions, which means there must be 2 imaginary solutions. We already found the x-intercepts. There are negative 3 and 4. So what about our y-intercept? Well, if you were to look at your table on your graphing calculator, you will find out that that is 0, negative 72. And now we got to go back to end behavior. As x goes to negative infinity, also known as the left, where does the graph go? And as you go to the left, the graph is going up, so the function approaches positive infinity. As x goes to positive infinity, also known as the right for this graph, the function is also going up to positive infinity. Another way you could have thought about that is this is a positive even power, and positive evens will go to positive infinity for both the left and right. So now you have an idea of what this is supposed to be when you are finished. Now remember, you already know 2 of your zeros. So you would just need to use synthetic division a couple of times, or if it was factorable, depending on which method you chose to do your factoring, you would end up with your, obviously, x plus 3 and x minus 4 from here. And then you would have to get one more term, which would be your x squared plus 2x plus 6, because it cannot be factored anymore. If it could, you would. And then it says list all the zeros. So when you were done with this problem, you would also say that x is equal to a -3, a +4, which we know. But remember, this has 4 solutions. We only found 2 reals. So by using the quadratic formula, this x squared plus 2x plus 6 would end up giving you your final 2 imaginary solutions, which would be a -1 plus or minus I root 5, again using completing the square or the quadratic formula. So that right there, that one question ties in the entire chapter, being able to analyze a graph, find intercepts, listing end behavior, factoring completely, and listing all zeros. So that's it for this chapter. This is Longo and I am out. See you, bye.